My name is Shimon. I'm the General Manager and CTO of the Data Solutions Division at ironSource. A little bit about ironSource. ironSource is a company that employs 800 people. The main business of ironSource is around EdTech. So we do advertisement. We compete with Google and Facebook. Today, it's Google, Facebook, and the third one is ironSource in terms of impressions, conversions. So if you have an app, if you are in the desktop, video ads, basically anything surrounding the advertisement world, we do it. And I joined ironSource 4 years ago when we were about 25 people. And we have different departments in ironSource, and we work in a P&L structure where every division or department has its own general manager, VP R&D. They have a task, they have the division, and they can go and do basically whatever they want. So we have a lot of programming languages, a lot of different solutions, a lot of different approaches to different problems. And the company realized very early that by going with this direction, each division will be free and can really move very fast. But on the other hand, it will be very hard to not overlap because there are many infrastructure struggles that you have to overcome, and they are similar to all the different divisions. So whether if you're a desktop division, mobile division, video division, whatever, everyone has to do CI, CD, automation, data, all of the cross stuff, right? So I will tell you today about the challenge that we had in terms of data collection and management and how we transformed our data pipeline that processes more than 200 billion events every month. So this is a production system, right? Into using Docker containers. So here in the graph you can see a little bit about the challenge of the events that we were receiving into our system. And just to emphasize, we use this pipeline to bill our clients. So literally, my salary goes through this pipeline. So if the pipeline is down, we don't get money, okay? It's literally as this, because when a user sees an ad, clicks on something, converts something, everything is tracked through the system. So it's very important to emphasize that we transform this pipeline to using Docker containers, and it is not a side project, it is not a pet project. This is the real thing, like the real production system. And here you can see the graph of the growth of the events, which was very, very challenging because they never stop coming. Like you gotta cope with the data, and it's like a river. It always keeps flowing. And you try to not lose events because every event is money. So we had to build a system that will collect, process, and store the data, one, for billing, two, for analysis, and further improvement of our own systems, right? Because when your business is serving ads, you want to be able to be data-driven, to have all the information, and then optimize your serving algorithms according to the data that you have. And this is exactly what we did. So I'll give you a short overview about the system itself, and then we'll deep dive, and I'll show you code snippets and Docker files of how we took our production system and started transforming it into Docker containers. And today, by the way, we're 100% containerized. So it's a data pipeline, right? And we have a lot of people that are using different programming languages. So the first thing you want to do is to have different SDKs. So you will be able to send data to that pipeline, right? So it's very basic. We use HTTP, HTTPS, JSON. So we wrote different SDKs. Everything is open source in GitHub with tests. And basically, you take the SDK and you start sending events. And we take care of retries and any problems that might occur during the process of sending the events. And after you send the events, the first thing for us to do will be to collect it. And we are using Amazon Web Services, and we are spread across 13 regions of Amazon. Okay, so we use Route 53 latency-based routing. So every user that's actually seeing an ad or doing any operation, he runs a DNS query and before sending the event, and he is automatically routed to the closest region. And this is very important because when you're collecting data, you want to receive it as fast as possible, and you want it to be very, very reliable and low latency. And actually, before we were multi-region, we were only in North Virginia, right? You start your business, you go to Amazon, you launch your instances in North Virginia. This is what everyone does, right? So, and we started identifying this issue, and actually when we went and spread our system across all of the different regions, we saw an increase of 5%, which is a lot of money. A lot of money. Just last year, ironSource revenue was 500 million. So think of 5% of that, okay? And technically speaking, you can understand that when someone reports data from Asia or Australia to America, you're in a problem because, and it is very hard to even cope with it because you don't even see it on your load balancer because it doesn't reach the destination. The next thing is that we enrich the data. So we receive it, we release the client, and then what happens is that we take all of the data and we perform enrichment and preparation before we insert it into our data warehouse. So things like IP to country, breakdown of the user agent, and basically any custom Python code within the pipeline that you want to do before you insert the data into your data warehouse. And this all runs on spot instances on Amazon. It's another talk by itself, but this is really helped us run in a cost-effective manner and provide a very cost-effective structure. And then finally, after we send the data, collect it, process it, we have to store it in some kind of a store. So today we support multiple different data targets, we call them. It's Amazon Redshift, Google BigQuery, S3, Google Storage, Elasticsearch, Postgres, Aurora. And basically, the system is here to provide a service to anyone. Today, we offer it to everyone. And instead of reinventing the wheel over and over again, like every company I meet, they either want to build a data pipeline or they already built it. And everyone's doing the same thing over and over again. So we offer it as a service. And now that you understand what we do and what our platform does, I'll go deeper into our technology stack. So we started from microservices. So it was a good start, right? Like we didn't have this monolith Ruby on Rails application that did everything because it was very obvious to us. Like you have to collect the data, like put it inside a queue or stream, then then process it, perform enrichment, and then store it to the data warehouse. So we started this way, which really helped us be agile and move fast because every microservice has its own life cycle, and it worked really well for us. Everything was decoupled, the system is distributed, you're infinitely scalable with Amazon, and we really use all of the best practices of Amazon, like auto-scaling and resharding automatically over our Kinesis stream. And now we use Docker. I'll go deeper into why we chose Docker and how do we use that and how do we do CI/CD with the Docker. In terms of cloud infrastructure, we're mainly based on Amazon Web Services, but we started with Amazon and Redshift because this is what we had. And then I had customers coming to me saying, Shimon, I want to send data to BigQuery. What am I going to tell them? I don't want your money. Like, what can you do? So you had support for BigQuery, right? Like, so we get everything to Amazon and then we send it to BigQuery. So it became like a sort of a mash, but still it's like 90% Amazon and 10% Google. And as I said, we're using spot instances, which lets you pay 10% of the instance cost. But you need to build your infrastructure to support outages. And we use another cool startup called Spotinst, which enables us to do that in a easier way. And of course, continuous integration. So everything is running in a way where you work with Git, you create a branch, you start working on it, and automatically for every commit we run our unit tests and our integration tests. And we have several different integration tests. So usually we run the big integration test before we go to master, but into staging and for every commit we run our unit tests. And just to give you the understanding, the big test is actually taking a day of data, which is like several billion of events, and streaming it through the new code, and then comparing it with the old code. Because this is the way we like figured, okay, how can you really, really, really test the system? So what the system does is receiving events. So we just have an automation system that takes a whole day and streams it in 1 hour instead of 24 hours. And we use CodeFresh for our CI/CD, and I'll elaborate more. So that's the architecture. If you want to build a data pipeline, be my guest. It's very easy. And I show this, and I talk a lot in different meetups, and we're Amazon Advanced Technology Partner, and I spoke at the keynote in Israel, and I don't think that it's a secret, because I don't think that we're like Coca-Cola with the secret sauce for Coca-Cola. It's just a lot of experience, a lot of hard work, and we learned a lot around the way, and we just needed the tool, so we created it, we're using it, and now we're offering it to other companies as well. So I really feel free talking about every nitty-gritty detail of the infrastructure, but today we will focus on the aspect of Docker and CI/CD. But feel free to catch me or send an email or ask any questions you would like. Be my guest. Docker. I really love Docker. So now we're going to go into the real deep dive of what we did and how we transformed our system. So our starting point was that we had pre-baked images in Amazon, AMIs basically, that had all the packages, the system packages installed. So we run mainly with Node.js, Python, and now a little bit of Go. So we would spin up an instance, install all of the packages we needed. Sometimes you need system-level packages, for example, the Postgres drivers or different stuff that need C bindings. And then we would make an AMI out of it, and every time it would boot up, it would get the latest code from S3 and run it. And the way it would work is that you would have an Node.js application. We would run it multiple times based on the amounts of CPU that the instance has, because Node, like many other interpreted languages, is bound to one CPU. So let's say you have 4 CPUs, you want to run 4 processes. And then we would run Nginx to load balance the traffic to those processes. And we would run supervisor to run the Nginx and to run the different node processes. And this was very, very common when we started. And the thing is, it was nice for a little bit, but then when we started rapidly iterating, we ended up with this horrible bash script that is like crazy to maintain, and like you don't want to do it at all, and it is really unmaintainable, and you need to like spin up a new instance in Amazon, and then like get the latest AMI, and then change stuff, and then create an AMI, and update the launch configuration, and then update the auto-scaling group. It's horrible. Don't do it. So we said, okay, we need a solution because we are unable to iterate fast enough, and maintaining those horrible bash scripts is not a good idea. So we said, okay, we want to go and do infrastructure as code. And back at the time, we had basically 2 valid solutions. Today, I think it's just Docker. But back at the time, there was a big hype about Chef. And we were considering Chef and Docker. And when we looked at it, Chef wouldn't help us in terms of the provisioning time. It wouldn't create an artifact that you can take. And we really like Docker. So we said, okay, how can we move all of our production systems into using Docker with the minimum effort? How can we just go live as soon as possible and not have a 6 months project and hire 10 people and do the migration project to Docker? Because then things never happen. So in order to do that, we said, okay, let's just take the current system that we have and just put it into a container. It's not the best thing to do. It's not the optimized way. But when you're trying to iterate and you're trying to do it in 2 weeks, I think that the best way is just to start and then iterate. Because otherwise, if you're trying to perfect it, you're never going to have a product, an artifact, or whatever. You're just going to be like, oh, let's optimize this and that and that and that. And we just wanted to go into production. So this is actually one of our first Docker files. It is very naive. So we used to run an Ubuntu machine in Amazon. So we said, okay, let's take an Ubuntu image, install whatever we usually install within our Ubuntu image, and just put the code there and run from there. So as you can see, we're using an Ubuntu 14.04. We're doing apt update, installing the Ubuntu updates. Then we're actually upgrading the whole system, which is not so good to do. But back at the time, like, this is what we did. So we just put it also, which is this upgrade. And then we would install Node.js from the Ubuntu repos. Don't do that. That is not recommended because it is always outdated, and that's not the best way to do it. But this is what we used to do, so this is what we did. And then you can see how we install the different dependencies using npm, and we run supervisor. So by doing this, it allowed us to basically have the same secure feeling, the same thing, only running inside a container. So we still had our code, we still had supervisor running nginx, running 4 or whatever processes of Node.js, but at least everything was containerized, and it was a shippable solution that you can actually take and use. And this is how our launch configuration at Amazon looked like. So we would have an auto-scaling group that will be configured with the user data. User data is what runs the first time when the instance launches up in Amazon. And we would always start with a fresh image of Ubuntu, then just update it, install Docker, log into the Docker Hub repo, and download the container and run it. So this really helped us because at this point we didn't need to deal with any AMIs or do any changes to launch configuration or all of our Amazon stack. Everything was fully dynamic, and it really, really helped us. Again, this is just the beginning. Here is also not so good because we're actually, again, we would dist upgrade, which means you upgrade your whole Ubuntu instance. And for example, you don't want to upgrade your, I don't know, your curl. It's not relevant to you, but it will still happen. And then we would install Docker again from the Ubuntu repositories, which are always outdated. So we would have not the latest Docker. And at this point, this is how a general project folder would look like. So we would have a Docker file, the one that we saw. We'd have a README that describes the repository. Then we would have a resources folder that would be split into 2. One folder would be the code, for example, index.js, your Node.js app, and the package.json, describing the different repos that you want to use, dependencies. And then we had an infra folder that had the nginx config, the supervisor config, and the config for the app itself. Now, again, this is not optimal, and this is not how we run today, and I will show you how we run today. But this took us 2 weeks. And we were in production after 2 weeks because we knew what we were doing, we understood what's happening there, and we weren't afraid. And after doing that, we were very satisfied. We were running with Docker containers. Everything was live and running. And then we said, okay, so now we are free to iterate. And it is easy for us to iterate because after you do the leap of faith and you start using a Docker container, then changing stuff there and shipping it is very, very easy. So like, I think that taking the smallest step you can in order to start using a container will actually help you do the transition faster.
What's the Docker version back then?
0, 6, 8, I don't remember.
You didn't have memory issues, crashing, workload?
So what we did is we tested it. We put it one by one, and it was okay. For our use case, I don't know, maybe for other solutions it sucked, but for us it was good. As I said, we have the test, the ultimate test. You take a day of data, you stream it through the pipeline, and you see what happens. Like, for me, there isn't any better way because it's real life. It is stress test because it's 24 hours in 1 hour. You can actually see everything working, and you can see the data being processed. So we did that, and it worked. So the next step was to get rid of Nginx and Supervisor because there isn't really any value to them. You would use them only because Node.js is bound to one CPU core. So you would say, okay, I want to run 2 Node.js processes, but how will I load balance the traffic to them? So, okay, I'll use an Nginx. And then, okay, how will I spin up Nginx and my Node code? So you would use a supervisor. But if there was a way to run Node.js in a way that it will know how to leverage all of the different CPU cores, then we don't need all of that. You guessed right, there is a way. And what we actually did is we used the cluster module. At that time, it actually just became stable. And what it does, it allows you to start the process, and then the process knows if it's the master or a slave. And then here what we do is we detect the number of CPUs by, you query it using the OS module, CPU's length. And then for every CPU core that we have, we would span another instance of it. And then the master would route the traffic to the slaves. So all the port 80 traffic goes to the master, and the master spans children by the amount of CPUs, and the data is routed there. Which is a great solution because it allowed us to get rid of all of the infrastructure work that we had around it. This is the Docker file back then. For the people who are familiar with Node.js, it was during the iOS fighting time where there was this horrible split in the community. And I was really afraid that it would be like Python 3 and Python 2.7. Thank God, Silicon Valley managed to fix it, and now we have Node.js 6.9.1 LTS released yesterday, which is very exciting. And what we did here is that we started using IOJS. We stopped updating all of our different packages because it was irrelevant to us, and we used the unattended upgrades, which allows the Ubuntu operating system only to do security patches, which we want, right? We want security patches, but we don't want just all of the different packages to be updated because, you're in a container. You're not going to run cron, so you don't care that there's a problem with cron because it's not running, right? It's a bit like it's a paradigm shift, but that's how it is. And then we would install the GPG key of the Node.js repository, download the code itself, and build it. And then we would always use the latest version or the specified version of the IOJS that we wanted. So here we're using a Docker variable IOJS version, and this is what we're installing. And this really helped us shrinking down our repository code, and now we don't have all of this infrastructure boilerplate crap that no one needs, and the Nginx configuration supervisor and all of that. We just have our application, which is great, which is what Docker is intended for, right? Running your application. So this really helped us. And we also upgraded our launch configuration in Amazon. So again, we stopped updating all of the images, just doing security updates. We started installing Docker from the official installation of Docker itself, which would install the latest stable version of Docker. Logging into our repository and running the container. Also using restart always. This is something that is very important. It means that if your app crashes, Docker will automatically restart your container. This is good for production because it fixes your crappy code and makes you keep running. You just need to monitor your logs, which is a different talk. And moving forward a little bit, this is a Docker file. It's hard to see, but this is a more latest version, which is already using Node.js version 4.1. It has all of the best practices that we talked about, of the security update installation from the Docker repo. And then we also started taking security into consideration. Docker by default runs everything as root within the container, even though it's not privileged. So it's not like real root, but it still has access. So we started using a dedicated user. We chose the user Ubuntu because that's the user that usually we used in Ubuntu. So again, you can see that there's like a pattern of like taking stuff that we know and trying to apply them to our new system. And then it becomes very, very intuitive because I have 4 development teams, and like syncing 4 development teams together sometimes can be tough. But when you try to preserve things that people already know, it's easier because they follow this pattern. Anyone have any questions up until now?
Did you consider using PM2?
So I looked into PM2. The thing is that PM2 is, it looks shiny and good, but it seems to me that running at the scale that we're running in production with PM2 was a little bit, I don't know, I didn't really like it for production.
You don't trust it, right?
Yeah, PM2 is you can run a container and it automatically monitors the container and it sends it into their system, and you have this nice dashboard where you can see every container and the CPU and memory and so on. So first of all, I don't want to pay them, and we have thousands of servers running this thing, right? So we had New Relic installed on some of the host machines. But yeah, we love Amazon. We usually go with Amazon. Side note, remember I told you about BigQuery. So what we did is we're using the container service of Google, Kubernetes, and we run all of our containers there. So it's really nice. It works really well. So I have like 7 more minutes, and I wanted to show you how we use Docker Compose, and then maybe show you a little bit of our production CodeFresh setup. So after we transformed our pipeline into using Docker containers, so it was obvious. Every project is like, it has a README, it has a Docker file, like it has a package JSON. It's like the default thing to go. And it really, really helped us. And then we started having applications that need to run several containers together, right? So you might have an application and then maybe a Redis. Or in this instance, we were running a container and Logstash that will read the logs and stream them into our Elasticsearch. So this is an example of the compose file that we would use. And the more interesting thing was that when we were using a specific container with Docker, we would just install Docker, write Docker login and Docker pull. But then when you're using Compose, you need your Compose file somewhere. And Docker Hub doesn't offer you to host the compose file. So you're then faced with the question, okay, what do I do with the file that describes my infrastructure? Do I put it in S3? Do I put it in the user data? Like, what the hell do I do? So I think there isn't a clear answer. It's like whatever you like. So we used S3. And here you can see that for machines that were using Compose, they would update security patches, install Docker login, then install the AWS CLI tools, download the Docker Compose file from S3, and then they would run Compose up. So this is what works for us. It's pretty nice because you have revisions and you have all your versions in S3. Some would say it might be dangerous because if someone deletes it from S3, you're totally fucked because no instance will spin up, right? Like this will kill your infrastructure. And it's a single switch to kill all of your servers. So that's true. I don't argue with that. But this is what we have currently. And then this is an example of how we actually use in production the Docker file. So we have an instance called the proxy, which receives data and sends it into a local RabbitMQ. So we have the RabbitMQ container, we have the proxy container, which this is the image, this is the configuration. You can see my, sorry. And then there's a link to the Rabbit container, and this way they can communicate. And every time we receive a message, we put it into our Rabbit container that is also backed by EBS, and then there's a Go process that pulls it and sends it into Kinesis. And actually, this really allowed us to go and put, now that I think about it, even more containers. Today, we have 4 containers running on our frontier servers. And it's really easy if we want a new functionality. So we just add another container, it reads from RabbitMQ, maybe duplicates the information into a different system or a test environment. And it's really, really easy because everything is really, really modular. And this is a final treat. This is an example of one of our latest Docker files that we use for the Go language. So Go is really nice, but it depends on your use case. So here, we actually moved away from Ubuntu, and we started using the Alpine image. Alpine is a very, very lightweight Linux operating system, which is tailored for containers. So your container is very, very small. It boots up very, very fast. And it's very, very lightweight. And this is actually the official Golang maintained containers. And they have the Alpine version. We just add the code. We use GoDep, which is something for installing the dependencies. Install the dependencies, add a specific user. Here we chose the user app. State the entry point, and this is how it runs. So this is an example of one of our latest Docker files. And this is basically our story of how we transformed our production environment into using Docker containers. And I think that it's very, very important to emphasize that this allowed us to cope with our scale. Because at the beginning, I showed you the graph, and within less than a year, we increased our traffic by 150 billion events. This is a lot. And if you don't have a robust system and a fast way to iterate, we wouldn't have done it. And it's very, very important, and it really, really helped us. So my suggestion to you will be not to think about it too much, just to try and do the smallest step to start using a Docker container. Because after you do that, you never go back. This is, I think, the way it works, and we never went back with that. So a final treat I would like to show you, besides my advertisement, is that our code first deployment. So this is something that really, really helped us because we were using Jenkins, and we were like when you move to all of those container systems, okay, so now we didn't need a build system for all of those containers, and then all of a sudden everything was a container. So like, okay, how are we going to build it? So we started by setting up our own Jenkins and slaves that will build it. Makes sense, right? But then you need to constantly update them and monitoring them, and then the Jenkins is down, and we had a lot of issues with that, and it was very problematic for us. So we heard about CodeFresh because it's very nice. It's a SaaS platform that does everything for you. And maybe it's important to emphasize that with the Atom Data, our product, we don't have DevOps people, QA people, developers. Everyone does everything. So there's a developer, he would install the Linux or configure the Docker file, and he would paint the button green, right? They would do everything. So it was very, very important for us, so my people can focus on the pipeline instead of focusing on building the Docker pipeline, right? So I'll show you an example. So we have different, as you saw, repositories. So we state where the Docker file is located. It's connected to our Git repo, right? We use the Docker file to build it. So it's really easy. You say, this is my repository. If you want to do it programmatically, you can do it. Then you run the different unit tests, integration tests, and deploy. I think that maybe I'll just show you. Hold on. I'll show you an example. So for people who use Jenkins, I think it's very easy to see, right? So you build the container, you push it, you run the different tests. This build was cached. They have great caching. Too good, I can't show you. It was cached. But basically, the main thing I'm trying to emphasize here, and maybe Raziel will show you more in depth, is that we're trying to help our customer focus on their business and not building data pipelines, right? Not dealing with the data, dealing with their business. So the same thing is here. Like, this is not my business, build pipelines. The same way I use New Relic or Datadog or whatever you want, I take a service and use it as I can. So we use everything as a service. And in this case, for our pipeline that I just showed you, we use CodeFresh. Thank you very much. And feel free if you have any questions.
So we're going to take like well, feel free to ask questions, and then we're going to take a couple minute break. So did you have a question?
Yeah. So how frequently do you update the binary?
Every commit.
Every commit? Okay.
Yeah, it's become very easy. You know, you just, every commit, there's a feature branch, staging, and production.
Okay.
So whenever like you build a feature branch, there's a feature environment for you. Then you pull requests into staging. People look, they approve, don't approve, say your code sucks or it sucks less. And then when it's merged into staging, it is automatically built, shipped into Docker Hub. And then our staging environment is automatically updated.
Okay.
So you have the JIT flow in it, or you set up the branches by naming it staging, feature branching?
Yeah, feature, staging, production.
So CodeFresh takes you from GitHub till Docker Hub, right? And after that, is it some Kubernetes? I think I missed the initial part.
Yeah, so we have Kubernetes and we have dedicated machines that just run Docker. We have ECS. We have a complex deployment. So we currently use CodeFresh with the CI capabilities, and we're starting to use the Kubernetes capabilities to check if it works good for us. I think that it will. But it's a little bit more complex with us because we have a deploy service that knows how to deploy a container to Kubernetes and ECS and different locations, which we had to build because there wasn't one, unfortunately.
So deploy service makes sure that which version to use, right? I mean, who knows that there is a new container and now you need to refresh your old binaries?
Yeah, so it's either a build commit that it was committed to Docker Hub, and then there's a post commit hook that goes and does like a rolling deployment for all the system. That's one option. Another option is for some systems that receive traffic from a load balancer, the traffic is always going like this. And all of the containers, all of the instances are always going up and down. So when they go up, they always pull the latest. So every time a new instance will go up, so like it's a very, very gradual deployment along the day.
So you don't force the deployment with
Depending. We have two both use cases. It's either we go like deploy and then it's like blue, green, like takes a new one up and takes the other one down, or gradual.
you just use the latest stack.
Yeah, it's not rocket science. Okay, thank you very much.